Hello, Absolute Mathman here. In today's video, we're going to talk about how to estimate expressions upwards and downwards. This mathematical skill is important in my opinion if you want to be good at math, but they often forget about it at school. So what is it? It is using simple facts such as the fact that for all real x, the sign x is between -1 and 1, and that for all real x, x squared is always a non-negative number, and that, for example, if x is greater than 1, x squared is greater than x. So we are talking about how to use this kind of simple facts that estimate a more complex expression or function into a simpler one in mathematical problem solving. And here I'll give you some problems to start with. First we ask, which is greater? 1212 plus 3434 plus 5656, or 2323 plus 4545 plus 6767. Second, we have a mathematical expression, x squared plus sine x plus 1, and we need to prove that it is positive for all x in real numbers. And third, we have a triangle with sides 3 and 4, and we need to find the greatest possible area the triangle can have. If you want to try the problems now, you can pause the video, and if you have any trouble, continue watching for some hints. So here are some hints. For problem number 2, we are hinted that x squared is always positive and that sine x is always between -1 and 1. Try to use these facts to estimate the expression. In problem number 3, you are hinted that you should think of what kind of a triangle could be the biggest, and then prove it is correct. If you want to try the problems again, pause the video, and when you're ready, keep watching to see some ways to solve the problems. And starting from the first problem, how to solve it. In this one, we had to compare two numbers, and we can start from the fact that, well, 1212 is of course less than 2000. This is a phase in the middle that may not be required to be written there, but I'll just write it there for clarity. And this is of course less than 2323. So here we see a clear difference between these two. In a similar way, we can say that 3434 is less than 4000, and 4545 is of course greater than 4000. Yeah, and lastly, we can conclude that 5656 is less than 6000, which is less than 6767. And when we combine these results, sum them up together, we can come to the conclusion. And now we clearly see that the correct answer for question 1, which number is greater, is this one. And we are ready with problem number 1. In problem number 2, on the other hand, we had to prove that a certain mathematical expression is always positive. X squared plus sine x plus 1. So how could we estimate that expression downwards or upwards? We want to estimate it downwards because we want to prove that it's bigger than a certain number, in this case 0. So we can, for example, estimate x squared to be always positive or 0. And we also know that sine x is always between -1 and 1. We can write it up here. The important part here is that it is always -1 or greater. And with this information, we can estimate the whole expression this way. So we've got that x squared plus sine x plus 1 is greater than or equal to 0. But that's not enough because we wanted a strict inequality. How do we do that? We split this into parts. In 2 cases, because x squared gets the value 0 in only one case, that is x equals 0. So we will study first the case x doesn't equal 0. We get a better result for this one. We get that x squared is greater than 0. And this leads to the fact that the whole expression is strictly greater than 0. Like this. And now we only have to check the case x equals 0. Now we can just plug in the 0 instead of x. Zero squared equals 0, and sine 0 also equals 0. Which makes the whole expression equal to 1 in this case. And that is strictly greater than 0. And we are ready with problem number 2. And finally, in the third problem, we have a triangle with 2 sides given, and how to find the greatest possible area of this triangle. Well, we can go for a guess. So let's start from this case where the angle between the side with side length 3 and the side with side length 4 is right. And in this case, the area is very easy to calculate. It equals 3 times 4 divided by 2, which equals 6. And what about the case where the angle isn't right? Then if we want to prove that the greatest possible area is 6, then we need to prove that for all triangles that satisfy these conditions, the area is at most 6. So let's consider these 2 cases where the angle between those 2 given sides is acute, and then we have this other case where it is obtuse. But in both of these cases, we can mark the height of the triangle with h, and we can mark this little line segment here with a, and also this one we can mark with a. And now we discover that according to Pythagorean theorem, h squared plus a squared equals 3 squared. And what we see now, we see that a squared is positive. A is strictly positive, it can't be 0 or anything, and a square is always greater than 0, so since that is greater than 0, we can underestimate this expression to be greater than h squared. And since h squared is now less than 3 squared, and h and 3 are both positive numbers, we can write that h is also less than 3. And that means the area of the triangle, which is 4 times the height divided by 2, is now less than 4 times 3 divided by 2, which equals 6 again. And since we have now proven that all triangles satisfying the conditions, they have a side of length 3 and a side of length 4, all have an area of 6 or less, and this is our final answer. And now you've been introduced into estimating complex expressions by stating that they are greater than or less than a particular simpler expression. And hopefully that helps you with solving math problems. If you want to see more math, please hit the like button, subscribe to my channel, and thanks for watching.